Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from fourth group. I want to introduce the members of the fourth group, namely Urwit Rizky, Nur Ahmad Mahmudi, Ahmad Wahidin Al-Masodi, Rizky Fitriana Dewi, Ainur Rahmah Malati, Tiffany Tamimatus Salsabila, Saifa Aprilia Sitkuni, and Muhammad Masyadi. In this occasion, we will presentation about synthesis of Schiff base from vanillin and p-aminofenol. Next. What is Schiff base? Schiff base is a chemical compound that is formed from the reaction between aldehydes and primary amines by condensation and produces byproducts in the form of water. Synthesis of Schiff base compound using the grinding method. In the grinding method, reaction occurs through generation of aldehydes by grinding of crystal of substrates and reaction by mortar and pestle. Reactions are initiated by grinding, with the transfer of very small amounts of energy through friction. Next. The purpose of this practical is the first, to determine the physical and chemical properties of Schiff-based products from the vanillin and p-aminofenol by grinding from 20 minutes using a lime catalyst. The second purpose was to determine the characteristic of the Schiff-based compound from vanillin and p-aminofenol using the grinding method for 20 with a lime catalyst using spectroscopy instrument of UV-Vis, FTIR, HNMR, and GCMS.
Okay, the procedure. The first synthesis of Basa Schiff from vanillin and p-aminofenol. A total of 2.43 gram of vanillin compounds, 16 millimole, was added to the mortar, then add 1.75 p-aminofenol, 16 millimole, and then melting point test. The melting point of the compound is measured using the melting point apparatus. Solubility test, uh, solubility in 2 milli of this water, chloroform, acetone, ethanol in a test tube. And then identification, UV spectroscopy. The synthesis with, with ethanol with concentration. Analyze of Violet range of 200 until 800 nanometer with a Curie variant UV spectroscopy. Next, identification using FTIR spectroscopy. Uh, Analysis the air spectrum of the analysis compound in the wave number range 4,000 until 400 centimeter. Identification using GCMS, the synthesis compound with a concentration of 50,000 ppm acetone solvent. Identification using HNMR, the sample is deposited in the CTCL tree and placed in a glass container or small tube. Then irradiation with radiation wave at the frequency of the electromagnetic radiation. Okay, next.
Synthesis of Schiff-based compound, vanillin and p-aminofenol, and by using the green method for 20 minutes, then catalyze with volume of 1 milliliter, produce a Schiff-based product in the form of a yellow liquid. Next, the mechanism for the formation of Schiff-based compound occurs in two stages. The first stage begin with addition of primary amine from p-aminophenol to carbon in the secondary group from vanillin. Carbon which has a positive charge will be attacked by primary amines which act as nucleophilic, resulting in the release of proton from nitrogen and the gain of proton by oxygen. The second stage is protonation of the hydroxy group, which will make the group into water. Next, the water will release in elimination reaction and then is released proton from the amine group, so product of synthesis is formed. Next.
Based on the melting point test, it was found that the synthetic product had melting points in the range 188 until 190 degrees Celsius, while vanillin and p-aminofenol had melting points of 80 and 187 degrees Celsius. Next. Apart from physical tests on the synthesis product, solubility tests were also carried out using several solvents such as 0.5 molar natrium hydroxide, aqueous, ethanol, chloroform, and acetone. When the synthetic product were tested for solubility at 0.5 molar natrium hydroxide, the product was completely dissolved and the solution had brown color. Acid-base reactions were related to the solubility of the product in natrium hydroxide. Phenolic groups contained in product compounds that have acidic characters. The presence of hydroxy ions from natrium hydroxide will facilitate the release of hydrogen ions from the phenolic group. Then a sodium salt will be formed when the Schiff-base anion is obtained from the release of the hydrogen which bind to the natrium ion. The formation of the salt causes the product to dissolve completely in the air. The solubility test of the product in aqueous show the only part of it was dissolved with colorless. In ethanol solvent, the product was partially soluble with a smaller amount of sediment than distilled water, and the color that is found is dark yellow. In aqueous and ethanol solvent, the product is partially dissolved because distilled water and ethanol tend to be polar. The chloroform solvent cannot dissolve the product because the difference in the level of polarity and colorless. Meanwhile, when the product is dissolved in acetone, the product will completely dissolve with a clear yellow color. Acetone can dissolve the product completely because it has almost the same polarity level as the product, namely semipolar with a polarity value of 0.335. Next.
The result of the analysis using the vivid spectroscopy instrument showed that the absorption peak was localized from the P to P star transition at wavelength of 258 nanometer, and the shoulder peak at 383 nanometer showed an N to P star immunogroup transition. The spectra are generated because the product compound absorbs electromagnetic radiation. The absorbed energy caused the electron in the product compound molecule to experience excitement from the basic energy level to a higher energy level.
This is the FTIR spectrum of the reactant and product issue below. In the F spectra that belongs to vanillin, it shows the presence of carbonyl absorption at the wave number 1664.841, and in the A spectra belonging to p-aminofenol, there is an absorption of NH group at wave number 3284 and 3341. From the two reactants, a Schiff-base compound product is produced, which is indicated by the presence of a typical absorption of the imina group at the wave number 1594, which can be seen in the A until D spectra. In the resulting product, it can also be seen that the loss of carbonyl group from vanillin and the NH group from p-aminofenol.
HNMR spectrum from base Schiff synthesis product shown below. On chemical Schiff, 3.73 ppm shows singlet signal with 3 protons that indicates methoxy signal. Singlet signal with 1 proton that indicates hydroxy appears on chemical Schiff 5 ppm. Then, some aromatic proton signals appear between chemical Schiff 6 until 7 ppm, that is on 6.65 until 6.96 ppm, 7.1 ppm, and 6.7 until 7.1. There is a signal that indicates imine that appears on chemical Schiff 8.36 ppm, where the chemical shift of imine is the greatest due to the influence of the p-covalent bond, aromatic ring, and electronegativity, so that the electron density decreases, which makes the imine group unprotected.
The other characterization of the synthesized product is GCMS characterization. Next, let's see the chromatogram from the synthesized product. From the chromatogram, we know that the sample have been successfully separated to 4 compounds, so it has 4 MS spectra. For the first spectra, the result has showed that there is 4 spectra and the base peak occurred at 109 molecular weight, as well as the molecular ions. The value correspond to the relative mass of p-aminofenol. Next. The first spectra can be represented by the fragmentation pattern. We can see that the molecular ions have the fragmentation pattern with the highest molecular weight, that is 109. Next. For the second spectra, the result has showed in the six spectra, and the base peak occurred at 151 molecular weight, as well as the molecular ion. The value corresponds to the relative mass of vanillin molecule. Next. The fragmentation pattern of second spectra. We know that the molecular ions have the fragmentation pattern with the highest molecular weight. Next. And then this is another fragmentation of second spectra. In this fragmentation, we can see that 151 molecular weight as the molecular ions. Then the third spectra suspected to be an impurity of p-aminofenol, so we didn't analyze the spectra and fragmentation pattern. Next. From the fourth spectra, we can be seen that the base peak as well as the resulting molecular ions occur at 243, and it has the same value as the relative mass of Schiff-based product. The fragmentation pattern can be shown like that. From the fragmentation pattern, we know that the base peak is 243, which has the highest molecular weight than the other peak. Next. And then another fragmentation of fourth spectra, which is represent the product of Schiff-based synthesis. We know that 243 is the highest molecular weight and relate to the relative mass of the product. From the research, we can conclude that the synthesized product has characteristic that is yellow solid and the melting point between 188 until 190 degrees Celsius. And then the solubility test is carried out in various solvents such as aqueous, natrium hydroxide, ethanol, chloroform, and acetone. In natrium hydroxide and acetone, the product completely dissolves, partial dissolved in aqueous and ethanol solvent, and not dissolved in chloroform solvent. Then, when the product identified using UV-vis instrument produce absorption at wavelength 383 nanometer, that show immunogroup transition. And then identification using FTIR instrument produce typical absorption at wave number 1592 centimeters until 1594 centimeters. That is the absorption for immune functional groups. Identification using the HNMR instrument produce a proton signal at chemical safe 8.36 ppm that indicates immune. And then the last identification using the GCMS instrument produce 4 peak signals. Okay, that's all for our groups. Thanks for your attention. Wassalamualaikum warahmatullahi wabarakatuh.